Okay, so that sets us up now to work the second derivative analysis. The second derivative analysis determines the intervals of concavity. Find the intervals where the curve is concave up. Find the intervals where the curve is concave down. The first derivative analysis is used to determine the intervals of increase and decrease. The second derivative analysis is used to find the intervals where it's concave up and concave down. The procedure is identical, except that for the second derivative analysis, you use the second derivative, and the conclusion has to do with concavity. For the first derivative analysis, you use the first derivative, and the conclusion has to do with increasing, decreasing. So, the procedure is the same. Suppose we're given, so I'm given a function here, and I'm going to use my original given function is x to the fourth minus 24x to the second plus 2. All right? And so what do? We need to do the same thing as before. We need to find the critical values. But for the second derivative analysis, we need to use the second derivative to find all these values. So, derivative number 1 has exactly one purpose, is to get us to the second derivative. The first derivative is 4x to the third minus 48x. The second derivative is 12x to the second minus 48. Once we found the second derivative in the second derivative analysis, you're no longer going to use that. So, find the critical values. This is the same song, next stanza that we did earlier. Type 1, excuse me, type 1 is where the second derivative is equal to 0. So 12x to the second minus 48 is equal to 0. Let's factor out the 12. In fact, let's do this. Let's divide everything that appears by 12. So this is equivalent to x squared minus 4 is equal to 0. This is equivalent to x is equal to positive or negative 2. And then type 2. Well, what do we know about type 2? Well, that's where the second derivative does not exist. But is it clear the second derivative is a polynomial? We know polynomials exist everywhere, so we would say there are none because it's a polynomial. All right? So these are the values that cut the number line. We do precisely the same analysis as before. I'm going to write my number line down here. Here's negative 2 and positive 2. And now we select representative values from each of those regions. I'm going to select negative 3. I'm going to select 0. I'm going to select positive 3. You're free to choose any values you like. I'm just going to choose numbers that are easy to work with. And now what do we do with those representatives? You evaluate the second derivative. This is the analysis part of the second derivative analysis. Evaluate the second derivative at each of those green, in this case, negative 3, 0, 3, each of those representative values. So we need the second derivative at negative 3, which is 12 times negative 3 squared minus 48. And if you do that computation, that works out to be 96. You can compute that with a calculator if you like, but that works out to be 96, which is greater than 0. So if the second derivative is greater than 0, what do we know about the concavity? We know concavity must be positive. This curve, concave up. The curve must be concave up, so in this interval, the curve is concave up. Then we compute the second derivative at the next representative value. You do not use the cut values. The cut values are only used to partition the number line. You evaluate the derivative at these representative values, at 0, at negative 3. I'm going to be doing 3 here in just a moment. So this is 12 times 0 squared minus 48. It's not too hard to see, that's negative 48. This is less than 0, so the curve is concave down in that region. And then same song, third stanza. So this is 12 times 3 squared minus 48. It's not too hard to see, that's also going to be 96, which is greater than 0, so the curve is concave up. So now we can state our conclusion regarding the intervals of concavity. Find the intervals of concavity. So our conclusion then is that the function is concave up. Function is concave up, my little symbol for concave up, on the interval from negative infinity to negative 2, and the interval from 2 to infinity. And the curve is concave down on the interval in between from negative 2 to 2. So everything you learned using the first derivative analysis copies over to the second derivative analysis. In terms of the computations, there are some differences. Of course, you use the second derivative, and the conclusion deals with concavity, not with increasing, decreasing.